Welcome to the lecture series in computer science on principles of deep learning. In today's session, we are going to focus on TensorFlow frameworks. And the agenda of today's session will be an introduction to TensorFlow library, its various operations, the variables, how to define the variables using the TensorFlow frameworks, how to reshape the tensors and how to extract the data from the tensors. Moving on, we have very different data frameworks while dealing with the deep learning, and over the years if you see right from 2012 or from before of that to till 2017 or after that, we have the various frameworks here, and here we are going to use TensorFlows and Keras for our deep learning models. So, this was released in the year 2015. Now, moving on to the actual definition of a tensor. A tensor is an algebraic object that describes a multilinear relationship between the sets of algebraic objects related to a vector space, and these tensors are generalization of scalars and vectors. So, if you see here in the example, if you take one particular object, algebraic object, which discusses some linearity between a set of objects, we call it as a 0-dimensional tensor. And if we have a set of values arranged in form of an array, we call it as a 1-dimensional tensor. And we already know that if there is an x and y axis or a mapping between rows and columns, we call it as a 2-dimensional tensor. And here it is a 3-dimensional tensor, 3D tensor and 4-dimensional tensor. So, these are the various examples of how the tensors will be represented. Now, moving on to the important concept of a shape and a rank. So, what does a shape indicate? What does a rank in tensor indicates? Usually, a rank is the degree in which that particular tensor is being defined, and shape is the size of that particular dimensional array. We call it as a size. So, see here, if you take just a value of 10 in a particular vector, we call it as the rank is 0 and the shape is 0. So, there are the size is not been mentioned as well as the dimension is not been there. Now, moving on to a single dimensional vector, this represents the degree is 1 and the shape consists of 3 elements. So, individual size we call it as the dimension, what each dimension contains the size we call it as the shape. So, now moving on to the other types, if you consider a matrix, this matrix is 3 by 2 matrix we call it as, because 3 row elements and 2 column elements have been there. If we consider this dimension, we say that the rank is 2 and the shape is 3 by 2. The rank is 2 degree. Okay. Then we considered a 3-dimensional tensor over here. Under this 3-dimensional tensor, the rank is 3 and we call it as the shape as 3 by 3 into 3. So, the blue part represents one particular tensor, the red part represents one more tensor and the orange part represents the other tensor. So, here in this way we can say that depending upon the degree in which the tensor is defined, we will represent numerically like this. Now, moving on to the fourth type, that is 4-dimensional tensor and the 5-dimensional tensor. We consider it the rank as 4, the shape is 7 by 3 into 3 into 3, and here like this we are going to construct it, and in next subsequent slide I will show you pictorially how this particular shape is being defined, because when we are dealing with deep learning models, we say that layered approach, we say that so many hidden layers the neurons has to be represented. So, in defining in defining that particular data set in form of the neural hidden layers, we have to say the shape of our particular data set. So, in defining that, this particular value is very important. Similarly, the 5-dimensional tensor if you take the rank is 5 and the shape is 7 into 8, 7 by 8 into 3 into 3 into 3. So, this represents the different types of sensors, how we have to use it. Now, how this has to be incorporated in Python library? We have to see the actual syntax further. Now, see here, import TensorFlow is the package name, as some variable name TF we are defining. Okay. And how to use this? If we say here T is equal to TF dot constant of 4 and print T, how it has to be defined in form of a tensor. See here, we are mentioning here the constant is 4 value, there is no shape value we have not defined, and the type of that particular data is of integer type we are taking. Okay. So, like this we need to define our tensor. Any constant value, if it has to be depicted in form of a tensor format, this is the syntax in case of the Python. Now, see here the same constant how it is being defined in case of a tensor. So, if you take TF constant 2, 3, 4 and that you are taking within the square bracket, the same will be depicted here in form, we are mentioning the shape as 3, because it is a one dimensional vector which is containing of 3 elements. So, we are mentioning the shape as 3 and data type here is the float data type, because the input values are 2.0, 3.0 and 4.0, which is the float data type. So, like this we need to define our tensor. Now, moving on to some little complicated tensors, how to be defined. See here, when you take this particular matrix, here we understood that there are 3 rows and 2 columns. The 3 rows values are 1, 2, 0 value, 3, 4 and 5, 6. And if you see the column values 1, 3, 5, 2, 4, 6. Like this we will be having any of the matrix here. Now, how to define this as a tensor in case of a Python library? How we will depict this? So, the data has to be taken in such a way like this. So, within the square bracket we are mentioning that 3 rows are there and 2 columns are there. So, the shape defines the order of that particular matrix. So, 3 rows. So, 1, 2, 3, 4 and 5, 6 are the input values, and the data type is here we consider as a float data type. No problem that if it is 1.0, 2.0 has to be given, not like that, we are just defining it as a float data type, that is it. So, in case of the Python TensorFlow libraries, if you want to depict a shape, the input data has to be taken like this, we need to apply the tensors in this particular format. Now, moving on to a little complicated data, if it is a shape of 3, 2, 5, how we have to define it or how we have to depict it. So, first we have to understand this shape is very important. So, when we are defining our data set, we will say layer by layer how much is the data set values we are going to take while we are applying some max pooling or some pooling layers we will be applying of. In those cases we have to understand how we have to depict the shape. So, see here 3, 2, 5 indicates there will be 3 row sets of data here, and each of the row contains 2 set of values, where each within that there are 5 different values. So, this 3 indicates the initial rows, these 3, and this particular 2 indicates under each of the 3 subcategories you have 2 particular rows within that, and this 5 indicates individual 5 different values are there for that particular data. Okay. So, we are defining the tensor now. These are our input values. See here 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on, like this we are taking the input data set, and this has to be depicted in form of a tensor with the shape of 3, 2, 5 now. Then how we have to define here? We have to take the data set here. See, individually within the square brackets the values have been taken, and depending upon the dimensionality shape we are defining how it has to be segregated. So, this is pictorially can be represented. There will be 3 row categories and each will contain 2 particular rows, and there will be 5 elements of each. Like this we can define a tensor. Now, moving on, how this tensor flow will be again each individual part what it depicts. Here with the first within a tensor it accepts the 3 parameters. Okay. So, these three parameters, the first one is the value parameter, second one is the shape parameter, and the third one is the data type. And within the shape we will mention how much of dimensionality it contains also. Okay. Now, moving on, what type of operations we can do with these tensors? Well, we are working more with the TensorFlow libraries, we will just utilize the built-in functions, that is it. We should understand that when two tensors can be added, when they can be multiplied, or when they can be subtracted, or whether we can do any divisions with respect to tensors, all this can be done. But to perform these operations, we need to say that the two tensors, the shape of the two should be compatible. We mean that the shape of the two to be compatible in order to perform these operations, and you need to perform element wise operations between any two tensors. So, like this we can do any type of operations with the tensors. See here, in this example we have been given to add two tensors, tensor addition as well as the tensor multiplication. This example is been given over here. Element wise operations will be performed, and these operations are performed only when they are compatible in their shapes. So, these can be performed only when they are compatible within the shapes. See here, in case of a multiplication, here A is a tensor, B is a tensor. We are applying the multiplication operation, and here if you see the result, how we achieved the result is when we are performing the element wise operations. Okay. Now, moving on, there is a concept called broadcast stretch. What do you mean by this broadcast stretch? So, whenever you take the input of two tensors, see here it is a tensor with x of 3, and here y is a tensor with value element 1. Now, whether how the operations when you perform an addition or multiplication, whether these two are compatible, we have to check. In checking, so we are saying that if any particular tensor is having a value of only one element, then broadcast stretch of tensors will happen. So, a one element can be compatible with any of the dimensions of the tensors. See here, there are three elements are there, and if I say to perform a multiplication operation with a single element of y, the element of y is only of value of 2. So, how this happens is it virtually creates two more elements over here. So, individually these elements gets multiplied with the base elements of the x. So, 2 into 1 2, 2 into 2 is 4, 2 into 3 is 6. So, this is permissible. So, how we say it is permissible? Because they both are compatible. So, we got the result, and resulting contents of shape size is 3. Similarly, here also take the second example, example 2. Here A is of 3 elements, B is 2 by 3, whether you can perform the addition, that is the question over here. So, addition can be performed or not. See here, A is again virtually be replicated as it is a one vector, 1 2 3 have been replicated again, replicated here we are using the word called stretch. Okay. So, again these 2 by 3 elements individually they got added, see 1 plus 1, 2 plus 2, 3 plus 3. So, we are getting a result of 2, 4 and 6. Similarly, here 1, 4, 2, 5, 6, 3. We are getting a value of 5, 7 and 9. So, using a concept of broadcast stretch in sensors, the two sensors can be performed any type of operations like addition, multiplication, etc. if we say that the tensors are compatible. Now, this is one more example of a broadcast whereby if you given the values of x and y with one single element also, and you wish to perform addition, the virtual elements have been added. See here, these are the virtual elements. Broadcast stretch is happening over here. So, each individual element wise addition is being performed. So, 1 is added to 4, again 2 is added to 4, 3 is added to 4 and 5, 6, 7. This is the resulting of the tensor. So, these type of operations we call it as a broadcast stretch, which is very important in case of the tensors. Now, moving on, till now we have discussed so many additions, multiplications, how two tensors will be performing of. So, this is the rule over here. So, two tensors x and y are said to be compatible if their dimensions and shape are same. This we already know. If they are of the same dimension, same shape, we can very well do the addition, subtractions, etc. Okay. So, see here, x is of an array, y is in an array with the elements 2 by 4 and you are getting a resultant. The first is of a simple case. Now, what is the other case? We see that there is one of the component with dimensions that has a shape of 1, then we say that those two tensors are compatible. So, using this methodology only, the other tensors what we have taken broadcast stretch that has happened only because of this. So, consider these three examples now. Example 1, x is a 2-dimensional array and there is an one component dimensionality here, one component dimension of shape 1. So, because of this the resultant is 2 by 4. Similarly, in case of a 3-dimensional array, one of the elements is 1-dimensional. So, because of this the resultant tensor is 2 by 4 by 3. Similarly, here consider the third example which consists of one component, single component shape. So, because of this the resultant consists of 2 by 4 by 3. So, hence we conclude that the compatibility of the tensors is possible even if the dimensions and shapes are different, but there should be one component of shape 1. Now, what do you mean by variable tensor? How it has to be declared? What is the syntax in case of a Python? How to incorporate this or implement this? We say that a variable tensor is created using a built-in function called tf dot variable of. See here, it consists of a set of elements which I will show you in next slide. See, these are all the parameters which we have to supply when we wish to use this particular built-in function. So, I will give detailed explanation of this over here. So, the variable tensor accepts the first value as the initial value, and by default there can be no initial value, even if you send it also it is okay. Then second one is the trainable value, that is it will be true if the gradient tapes will keep an eye on this variable's usage. If you are say that this particular variable has to be make an eye point of this particular for use it for gradient, then you will say it is true. Then you have to validate the shape, by default it will be true. So, this is a built-in value, and if you say by default it is true, which says that variable to be initialized with an unknown shape value if false, and when it will take a false value if the variable is to be initialized with an unknown value. The shape of the initial value must be known. If you know, it will be true always. Then you have to give a name to the particular variable. This variable name is optional variable. Default the variable will be uniquely identified, okay, automatically unified. Then here the variable def is given, by default it is none, and you need to mention the data type. Usually it will be assigned to a value that is given initially, and we need to mention the shape, okay, what type of shape we are going to use for this particular variable. So, if we fill up all these values, we can create a tensor with the variable. So, here we can see a simple example in Python how a variable will be created. Now, see the first example, import TensorFlow as TF. This is an import library. From TensorFlow we are creating a value of variable name with the TF. Now, TF dot variable of, V is the capital letter over here, 1, 2, 3, 4. This indicates that we are going to print the x value, which shares something for us. TF is a variable and it consists of a shape of 4 elements it is having. The data type default we considered as an integer data type, and it consists of an array as an input value that has been given over. Okay. So, 1, 2, 3, 4 is the initial value over there. So, here is some of the other ways of defining the tensor variable. See here, you can have an integer, we can have a float value, we can have a string values of initial parameters that has been supplied, or you can have a variable with a true or false value, or you can even have a variable with the complex number 3 plus 4j. Now see, till now we have discussed with the shape value of, or we have taken the rank of 1. Now how to consider with the rank of 2, how to define the tensor with these initial values. Now see here, if you take a TF variable, again we are mentioning here the shape is, we are having a 2-dimensional. Okay, if you consider this, it can be represented as a matrix. See here, so this is 2 by 4 matrix, hence the shape is defined as 2 by 4 here, and data type is being mentioned, array is the input values we are considered. Now what for we are learning all this is, when we are working with a complex data set, we need to understand how a TF variable has to be defined, how, what value has to be given within this shape parameter. So when you do a complex program, we will get 256 comma something or 78 comma 60 like that. So at that time we have to understand that what that shape indicates, how many layers we are being considered with respect to the dimensionality. So for understanding of that, we need to understand the basics of the tensors. Now what do you mean by an attribute in a tensor, and how to just get individual parts of an attribute. We know that attributes is, a name attribute is there, shape attribute is there, data type is there, and the numpy input data set is there. So these are the attributes in a tensor variable. So if you want to display only the name, we can just say x dot name. So the name of the variable is being displayed over here. Then we are just taking here the shape. So the shape is 2 comma 4. So here we are mentioning that 2 rows values with 4 individual values has been taken. Now with respect to the data type, we are mentioning the input data type is of integer data type, and the data set values, if you give dot numpy, then it displays the input parameters. So like this we can individually retrieve the attributes in the tensor data set. So now here this side also the same TF variable is being taken for 1-dimensional array, and we are displaying the individual attributes, name, shape, data type, numpy, etc. and the values of that same variable name, what is its shape, what is the data type, and what is the input parameters that has been supplied is being displayed over here. Now moving on, how these tensors can be converted from constants to variables and from variables to constant. So two different types of examples have been given over here. See here, the first example we are defining as a constant and we are converting to a variable. So and then we are printing what is the full explanation of that particular type if you do a type conversion. So we are converting it to a variable, so it gets a name, it gets a shape, a data type, and the numpy data set. Similarly, if you are using variable you are taking and you are converting to a constant, then how the tensor is been giving you the value for you. So these are the two ways when we actually need, when we performing some real world applications, if you want to do a conversions between these two, using these examples we can convert from a variable to constant and from constant to a variable. And here this is also one more example taking of a constant and how the values have been, we are getting the with respect to a floating data type. Now moving on to what do you mean by reshaping in case of a tensors, whether any 2-dimensional 2 by 2 tensor can be converted into some other format, or some 3 by 2 can be converted into 2 by 3, like that how we will do restructuring in case of a tensor. So now take the constant, suppose we are taking a 1-dimensional constant tensor with 1, 2, 3, 4, 5, 6 values, and here this tensor actually been represented like this in the output. Now when you want to reshape this with a 2 by 3 format, so how it can be done, what the encoding, what we have to just express here, instead of after mentioning the constant, you have to mention in the same attribute function, you have to mention the shape 2 comma 3, then your tensor will be converted into a 2 by 3 matrix taking as 1, 2, 3 as the row element and 4, 5, 6 are the second row element. So in this way any of the data set can be converted or can be reshaped as you wish. Okay. Then see here, when you display this as an output statement using the print statement, then it is displaying the tensors like this with mentioning the shape and the data type. Now, how again to reshape it to 3 by 2? If you again want to reshape, what is the function that is used? TF dot reshape of x comma, x is the input type you already have, and you are doing it as a 3 comma 2. So, how it will be displayed? Now, see here, it takes 3 rows and 2 column values. Okay. So, our dimension has been reshaped now to 1, 2, 3, 4 and 5, 6 values. So, in this way any structure in tensor can be reshaped also. So, all these operations in tensors, whether you are doing an arithmetic addition, multiplication, or you are subtracting two tensors, or we are using the broadcast stretch method, or we say that any kinds of operations can be performed only when there is a compatibility and reshaping of the tensor structures. All these are possible with respect to the tensors. Now, how to flatten the tensors? If you want a 2-dimensional tensor has been taken and now you want to flatten it, you want to make it to a single shape, how you will do that? See here, this is 4 by 4 elements taken in a the matrix format is what? 2 rows and 4 columns. Now, this 2 by 4 input data set is being taken and it has been shaped, it has been given the shape as 8. So, it indicates that one single vector has to be displayed. Now, if you take this and print the x value, then your output will be a single dimensional scalar vector with the input shape as 8 elements. It consists of totally 8 elements, that is it. Now, moving on to the reshaping of these tensors using the constants, whatever, these are the some additional examples for reshaping in tensors. So, we have taken the data set 2 by 4, the shape is 2 by 4. Now, we want to reshape it as 4 comma 2 and there is a value called -1 in case of reshaping also we can apply. 4 comma -1 indicates that you have been taken 4 rows and 2 columns. Okay. So, this is reshaping, you have applied the reshaping in tensors and you say that instead of I want directly 2 by 4 by 2, we can use the -1 example in case of the tensors and we get the values as 1, 2, 3, 4, 5, 6 and 7, 8. Now, how this -1 in tensors can be applied? How it helps us in reshaping? Take one more example, reshaping of x comma 2 comma -1 comma 2. So, we have taken a full constant set of values and we are reshaping. See here, actually the array is being taken as a 2 by 2 fully. So, 1, 2, 3, 4, 5, 6, 7, 8. This is the data set that we have taken. Okay. Now, if we apply the reshaping, okay, reshaping 2 comma 2 comma -1 if you apply, see here what are the input values we got? 1, 2, 3, 4, 5, 6 and 7, 8. This is the reshaping of that particular tensors with the -1 value. Now, there is one more concept called slicing in tensors. What you will do? From the tensors taking up from particular rows instead of all. So, you need to mention the input, the begin from where we have to and how much is the size that you want to take, slice it. Okay. So, if you take a simple example for this, see here we are taking the input, full input in a matrix of the shape and we are slicing only this part. Okay. So, the output will be, see here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, 11, 12, 13, 14, 15, 16, 17, 18. This is the actual shape of the given tensor. Now, if you reshape it to this, okay, see here the slicing comes as 4, 5 and 13, 14. Only these values we have got. See here, this is the row that we got 4, 5 and here 13, 14, 15, 16. Only these 2 rows have been selected and it has been reshaped. Okay. This is the slicing example and one more example we wish to slice now. Then see here, out of all the outputs 4, 5, 7, 8 and 13, 14, 15, 16, 17, 18. You are taking the fresh tensor here data set and you are applying the sizing function here. When you apply this slice function here, we are using that, we are saying that second and third or the row or the row elements we wish to reshape our particular tensor. So, we got the tensor slice like this. So, these two are the examples for slicing of a particular elements from the tensor. Till now we have just discussed different possibilities of using various variables in case of the TensorFlow libraries. Okay. In subsequent classes we will get a detailed instruction of what are the other complicated functions or libraries available with respect to the TensorFlows, and how the data sets can be taken or uploaded using the TensorFlow library.